In this video, we're going to learn about pivot tables. But before we can fully understand the benefits of a pivot table, which is a tool within Excel, I want to first show you what a cross-tabulation is. We have here a set of data that lists out customers based on a survey that was collected, their age, gender, the store that they went to, and the type of fishing method that they prefer, using bait, using a spinner, or using flies to catch fish. If we wanted to understand a little bit about the details behind this data set, we would want to aggregate, or in other words, summarize the data. We'd want to understand how many people prefer each of those types of fishing methods. We'd want to understand what stores they came from, and most importantly, the combination of the two, which would inform perhaps some of our marketing strategy, or at least some of the supplies in terms of what products we should have available in those stores. So I'm going to quickly create some cross tabulations, and then we'll get into the pivot tables. Please follow along with the cross tabs before we get into the pivot tables. To start off, let's list those types of fishing methods preferred. To do that, I'm going to use a combination of formulas. I'm going to use the transpose function, and I'm going to use the unique function. Unique returns a unique list of elements given a specific range, which we'll select here. And then transpose, instead of listing it in rows, flips it on its side and lists it in columns. So if we click enter here, you'll see it's listed for us bait, spinners, and flies. And it has this blue border around it, which means that it's what's called a spill function. It doesn't all fit in one cell, and so it spills over into these other functions. And you'll see it's got a light gray function here in the formula bar because it is written here, but the data spills over into these ranges. If I wanted to understand how many customers shop for bait, I could do a simple count ifs function. And the criteria range would just be all of my data from the survey. And then I could use this heading of bait right here. If I close parentheses and hit enter right now, I'll get the answer for bait. But I want to anchor this so that I can drag it across. So I will anchor the references to this, and I'm going to anchor only the row here for my headers so that as I drag it across, it will move from column HI to J. So copy that, Control V to the side. You can also use the little autofill feature here to drag it over. So what I've learned is that there are 575 customers that prefer bait. What I don't know is how many are there total. So if I do a count here, we'll do a count of all of these customer numbers here. We understand that there were 1,500 respondents to this survey. We'll just put total over here. And what if I want to add an additional dimension? I want to understand not just how many people chose bait or spinners or flies, but where they were, what store they were in. Again, I can use the unique function here. I can select our list of stores, and here it's spilled over and listed those stores. So now I can use that same COUNTIFs function. This time I'll have two criteria. The first criteria range will be the type of fishing preferred. We'll anchor that range. We'll reference this header column here, and we'll anchor just the row. The second criteria is going to be the store. We'll anchor that range as well, making an absolute reference. And then we will reference this store name here, and this time I want my absolute reference to refer to the column, and I want the row to change as I drag the functions down. If I copy that, I can use Control C and Control V, or I can use this autofill function right here to copy it down. So now I can get a better feel for, across all of my data, where do people prefer bait, spinners, and flies. And of course, I could do some conditional formatting here, pick a quick color scale rule, and just say whichever cells have the greatest amount of data, I should color those. It looks like I have my greatest total number of shoppers here in Lehigh, and so if I sum these up here, I should be able to see how many customers I have in each of those stores, and sure enough, Lehigh is my most popular store. So we may want to look at this information as a percent of the total or something along those lines to get a better feel for it. In fact, if we wanted to do that, we could very easily type in this divided by the total here and get an idea of what that might be as a percent of the total. So if I copy that over, and then I will copy it down as well, and now when I format these, Control Shift 5 gives me a percent. We'll align them to the right. You can see here that relative to each of the totals, because we've anchored them appropriately, these are the percentage of customers that prefer each of those types of fishing methods based on their location. So I could reference this location right here, copy that down, and then it references the same headers here at the top. My total here, of course, would just be 100. So that's one way that I could start to look at this data. I may also want to understand the same questions not so much by location, but maybe by gender. And so here, if I were to copy these genders as another way to get this out of the list instead of using unique, I could use this same function right here, this countifs. Using countifs, my first range here will be the type of fishing. I'll anchor that, and then I'll reference this same header right here at the top, and I'm going to anchor the row. And then my second would be, this time instead of the store, just the gender. Again, we'll anchor that, make it an absolute reference, and then this time we'll reference these headers here over to the left. On this, we want the absolute reference to be the column, and then we'll close parentheses, copy this, and paste it through the whole thing, and we'll see again, we do have a total of 1,500 down here at the bottom, so we have all of the responses, and we have them reflected by their gender. These are some examples of how you could do a cross-tabulation of the data that's presented here. And it's taken us about 7 minutes to get through doing all of these calculations and adding a little bit of just light formatting to it. But there's a much faster way that we can do this same type of analysis, and that's where pivot tables come into play. Well, the examples that we've done here focus around counting. Of course, this could also be an average if we wanted the average age of something, or it could be a sum total. There are a lot of different ways that this data could be sliced or could be presented in a crosstab. But there's a much faster method to do this. So what we'll do is start by selecting all of the data. I like to start in the top left cell, press Control-Shift right and Control-Shift down to select the entire range. And I'm going to name this range as just data. I like to use named ranges because it makes it easier to reference, and if we need to update that range later on, we can do that in the name manager here under formulas instead of having to go change a lot of our references elsewhere. We'll create a new sheet here, and we'll choose to insert a pivot table, and when it asks us for the range, we can type in equals data, which is the name of that range. We'll choose to put it here in this existing worksheet, and we'll press OK. Another way that that can be done is if you are confident in your range of data being separated by itself, you can go to the Insert Pivot Table and it will try to guess at the range to select. But remember, if your range of data ever changes, you would have to come back in and manually update this. The default here is that it creates a new worksheet for you, which is fine. We can click OK. We'll wind up in pretty much the same spot whether we went through it that way or we went through the way that I showed with the named range. From there, you'll see over here on the left, we have what's called the Pivot Table Fields menu. And here it shows you a box for all of the columns that we have on our original base data here. And it gives you a filters section, a column section, a rows section, and a values section. Now what pivot tables are intended to do is to aggregate or summarize data that's held on another data sheet. We could also connect this directly to a database, but that's beyond the scope of this class. If we wanted to, for example, see a list of the stores, we could drag our stores here to the rows and it would list out each of those store names. It doesn't have any values yet here, so it's not really sure how to fill out the rest of the table, but we could take this store name again and just drag it here into values, and now it's giving me a count of how many shoppers there are at each of those stores. You'll remember over here, we got that count here by using the formulas method. And right here, we've done that with just dragging two things into the pivot table here, and that shows you exactly what the count is of those stores. In addition to that, we may want to understand what the average age of our customer is for each of those stores. If we drag this age here, you'll notice it defaults to summing that column. And the reason for that is the pivot table has recognized that that column contains numbers. And so its default method of showing numbers is to add them up or sum them. We can change that by going here to this value field settings, and instead of choosing sum, we can choose average. When we click OK, it changes that, and we'll need to format it to get it to show properly. But that is now the average age for each of these stores. So very quickly, without doing any functions, we can summarize data from a base data table. One of the keys to being successful in using pivot tables is to remember that the pivot table is all about aggregating or summarizing data. And as a result of that, it wants to display to you either the count or the average or some other method. If we click on value field settings here, you'll see we have sum, count, average, max, min, product, meaning multiplication, the count of numbers, standard deviation of the population, the variance or the variance of the population. All of those are ways that we can show aggregate information. So even though this store column contains text, it tries to aggregate, and the only method it knows how to do in that case is counting, so it defaults to that. We can quickly change pivot tables or add to them by sliding things off of this or onto it, depending on what we're trying to accomplish. Let's select this pivot table. We'll press Control-C, and we'll come back over here to our first sheet. And if we slide over to the right here, we'll try to replicate what we have here in this manual crosstab in this pivot table here. The first thing we can do is we can pull things off of the pivot table. Additionally, if we want to just clear it and start from the beginning, you can go up here and choose under Pivot Table Analyze, Clear All, and that will start with a clean, brand new pivot table with nothing on it. The first thing that we're trying to do is list out the stores to the left. We'll put them here. And you'll notice by default, it's sorted these by alphabetical order. Across the top, we would like to put this type of fishing method preferred. We'll do that here. Now it has this column label section and a row label section here, but it's got the beginnings of what we need. It's also automatically included grand totals for us so that we don't even have to add those in with a separate function. Now, it doesn't really matter which one of these columns that I pull in and place in this values field because we're trying to achieve a count. But if we choose a column that has numbers in it, we will have to make sure that we change it from sum to count. I'm going to choose to use the store field again and just put it in the values so that it's automatically counting. If we wanted to reorder these, we can click on a row, we can drag it up to the top and manually order them. So if we choose to order by Boise and then by Lehigh, just like we had before, and then Ammon at the bottom, you'll see here we have bait, flies, and spinners, so we need to pull the spinners over to the left to match what we had previously. We can also resize the columns here a little bit to make sure that they fit appropriately. One of the things that pivot tables will do is automatically resize the columns to try to fit the data. And this can be helpful, but it can also be frustrating depending on the formatting. So to get around that, one of the things you can do is go to Options here, and you can choose right here to uncheck this Auto Fit Column Widths on Update so that as things update, it won't mess with the column width that exists already. Now we can see very clearly here that with only a few clicks, less than a couple of minutes worth of time, we have the exact same table replicated here right next to it. We also can go up to this design area here and automatically choose different layouts and ways of viewing the data without having to make any manual formatting changes. Let's choose this option here. With a pivot table, one of the things that you can do, if we copy this table here, we'll select the whole table, Control-C, and come down here and press Control-V. We can also change the sorting. So if we wanted to sort it based on where our total customers were, we could right-click here on this grand total, choose Sort, and then choose Sort Largest to Smallest. We may also want to do the same thing going across this way. So we can right-click on this data, choose Sort, and choose Sort Largest to Smallest. It just depends on how we want things to be sorted. Here you'll notice it's already sorted from largest to smallest, so that didn't change anything. If I change this grand total and choose to sort largest to smallest, you'll see it switches around to show that spinners is actually the largest, followed closely by bait and then flies. In addition to doing a count calculation, let's also do an average. We'll copy this pivot table by selecting the whole thing, bringing it down here. What we'd like to find out is the average age of those that purchase spinners, bait, and flies based on their gender. So what we'll do is we'll remove store from the rows And you'll see here it maintains the count for each of those. It just doesn't have an additional row, only a grand total row. And we'll add gender into the rows, which then puts them in here. It's still choosing to count the number of people that are in each of these buckets. We'll pull this count value out and we'll add age in. Again, by default, since it's a number, it's choosing to sum that field. We'll switch that to average. We'll click OK. So this is now the average age based on these types of preferred fishing methods. If we format this correctly as a number here, and let's just reduce our decimal points one more, these are the average ages. And what you can see is that actually there is a trend. Our bait, spinners, and flies customers all tend to be close in age regardless of their gender. So very quickly you can take a large set of data here, 1,500 rows, and come up with some insights that could change the way that you approach the business, or that you market to your customers, or that you have things ready to go in terms of supplies. If, for example, we know that customers that prefer bait happen to be older than customers that prefer these other options, we could take this pivot table, copy it down here, and we could look at what the average age is based on their location of shopping. Now, if I add this in, it's going to try to show both of these. For spinners, it will show the count of stores and the sum of the ages. I'll pull out the count of stores, and I'm actually going to pull out the type of fishing preferred, and I just want to look at the average age of those stores. So if I choose value field settings, average, click OK, and then I'll apply that same number formatting again with Control-Shift-1, I can see here that my average age for each of these stores is actually around the average of my total. So there's not really a clear customer grouping in terms of age across each of my stores. But with only a few clicks of a button, I'm able to validate that question or answer that question. Let's select this table and copy it. We'll paste it down here. To do some additional investigative work here, we can also add filters. So if, for example, we wanted to look at a specific store, we can drag that range into this filters option, and it adds it here at the top. I can choose one of those specific locations, or I can choose to select multiple items. And let's say I wanted to just exclude Ammon, Idaho, I could do that and see only the other stores, or I could choose only one store and we'll look at only Boise. Now that we have this pivot table filtered to that specific store, the insights here are going to be specific to that location. If we wanted to understand better the variability in age, we could remove this type of fishing preferred, and then we could add in age again. And this time, instead of choosing the average, we could choose the standard deviation. If we click OK, we can see here both the average age and the standard deviation of that age, the variability. We already know, though, that there is a difference between ages based on the type of fishing preferred. So what we can do is we could actually drag this type of fishing preferred here into the rows, and we can put it above or below gender. If we put it above the gender, you'll see it repeats for each of those, the heading here for bait, and then male and female. If we flip it beneath, you'll see it groups it by female and male, and then by type of fishing. In this case, I want to see if there's a difference between male and female within any of these subgroups. And what I can see here is that with fly fishing, females have an average of 32 with a standard deviation of just under 10. Males have that same average of 32, but the standard deviation is 12. So on average, you see more variability in age for a male shopping for flies than you do for a female shopping for flies. Filters can be helpful for another reason. If I wanted to include gender as well as a filter, I could pull that up, and you'll see these tables almost look like they're connecting, but they're still separate. We could drag them down here a little bit to show that separation. And I could choose to filter by just a specific gender if I didn't want to show all of that information in the table at the same time. In addition to having a filter here at the top of the pivot table that impacts all of the data, let's take another example by copying this table. We'll put it right over here. And this time we're going to list out all of the genders in the column, and we'll list out the store locations here. We're still showing the average age. Instead of adding a filter here to the top over on this box here, I can actually filter using these column labels and row labels. If I click the drop-down arrow, I can select one or more of the stores to include. I can filter them based on all of these conditions. I can filter them based on their values, and I can sort them, A to Z or Z to A. If I click more sort options, there are additional ways that I could sort. But for now, let's just uncheck Boise and exclude that store. And you'll see it's no longer included in my data set, and it's no longer included in my total calculation. If I wanted to do the same thing here in the columns, I could again uncheck male, and now I'm seeing females for Lehigh and Ammon. This enables us to very quickly understand what does my total look like if I exclude certain sections of the data. Again, all of this is able to be done with just clicking and dragging a few things around and not having to create entirely new crosstab tables for each step of the process. When we use functions like we did up here, if a data point changes in our original data, let's say that this shouldn't be 56, instead this was actually meant to be 12, our formulas here will update automatically and change based on that. So for example, let's look at one of our bait customers. If we include in Lehigh here that this one was in error and this should in fact be spinners instead of bait, if I paste this in, automatically my data updates here. But over here you'll see it retains, if I close that for a moment, you'll see it retains the same count that it had previously, which is now wrong. Anytime the base data set changes, we need to go under Pivot Table Analyze here and we need to choose Refresh All. This will update all of the pivot tables that have the same data source to show the new updates. One last thing to note about pivot tables. We have the ability to add an unlimited number of hierarchy levels to the pivot table. And if the box ever goes away, you can go back up to Pivot Table Analyze and choose Show Field List here. If we want to, say, move, instead of type of fishing as a column, we can move it under the rows. We could also add store under the rows here. You'll see that it continues to allow us to drill down. These little minus and plus buttons allow you to expand and collapse. If you wanted to expand or collapse all of them at the same time, you can go up here to the top, choose Collapse Field, and it will collapse all of them. If we click it again, we see we're at the top level. If we wanted to be able to drill into our data to get additional insight, we can just click the plus button to drill down to the specific level that we'd like to see. There are many ways that pivot tables are useful in doing both quick analysis and setting up to be able to refresh with new data sets as new information comes in. This is just an introduction to them. In our next video, we'll go through some of the more advanced things that you can do with a pivot table.